So hello friends. So today we are going to discuss about the multiple threads and their stake. So in the previous section we have seen how threads can be created, and we also explore the life cycle of a thread to some extent. So in this video we are going to discuss about how threads maintain their local variable and call stake. Each thread in the Java has a private stake associated with it. When a thread is created in a Java virtual machine, a JVM stake local to that thread is also created. So let me open a thread stack demo, and here you will see in this program we created a two thread. First one is a main thread which we didn't create, but the by default thread is a main thread, and second one thread is named as a my thread. So three things are happened here in the main thread. First one is the main method. This main method is invoked from the main thread. And remember, the main method and main thread are two different things. Okay, so main method is turn call method 1. Then third one is main method create and start a user defined multiple threading, right, which is named as a my thread. So now my thread simply call the method 2. Okay, so what will happen here? Java virtual machines stack is private to a JVM thread, and every method call that happen in that thread will have an entry in its private stake. Now what all can a Java stack store? So in this uh, in this program, if you will see that this method 1 will be stored in the main thread stack. Okay, and this method 2 will be stored in the my thread stack. So you will see like both of the thread have their own stack and they are storing their own methods. So now that we understood how stakes are created for the particular thread, there is often confusing among newly programmer that what if we run multiple thread with the same runnable object. Yes, we can give the same runnable object to the different thread, in which case every thread perform the same task in its own context because it has own stack, right, as we discussed earlier. So the program is here multiple thread same runnable demo, and here you will see that I created one object of my runnable, and then my runnable, and then I'm just passing the same runnable object in all the thread named as a t1, t2 and t3, right? So in this case t1, t2 and t3 will have their own stack and the local variable I in the run method, right? This I object or I variable will be stored in their separate local stack. So if I will run this program, and you will see the output here, you will see that there is a different output. T3 has a 0, T1 0, T2 0, then T3 going to increment with 1, 1, 1, then 2, 2, 2, 3, 4, 5 and 6 2 till 9, right? So as we have seen that every thread has a separate copy of the local variable because of its own stack. In the latter part of this series, we will have a look at how thread can access global or share data and how inter-thread communication happened. It's time to the summary. So each thread in the Java has a private stake associated with it, right? Created along with the thread. Then each entry in the JVM stack is called a frame. This is the important thing, right? In a point of interview. So a frame contains local variables, operand stack, method call, reference to a runtime constant pool, and the exception dispatcher. Then multiple thread can execute the same runnable since each thread perform the task in its own context. Then each thread can have it on runnable, right? So that's it for this part of our multi-threading series.